Good morning and welcome to CS 253, which will focus on parallel functional programming with Java, Android, and Spring WebFlux. I'll be giving several overview lectures at the beginning, starting with Part 1. Part 1 will give an overview of the course philosophy, the course contents, as well as the structure of the lecture material. It's probably very clear from taking a look at job postings, articles in the trade press, and other sources that there's a growing need for software developers who have skills that enable them to write parallel programs for a wide range of computing platforms, including mobile devices, laptops, desktops, cloud environments, and everything in between. This demand is driven by various advances in both software and hardware. On the hardware side, over the past several decades, we've seen a slight twist in what's known as Moore's Law. Moore's Law is a term that was coined by Gordon Moore, who was the CEO of Intel many years ago, and he predicted that the number of transistors on a chip would double roughly every 18 to 24 months. Now, for many years, this also meant that the speed of the chips, the speed of the processors, wouldn't double every 18 to 24 months. But starting in the mid to early 2000 timeframe, the speed stopped increasing, but the number of transistors in the chip has continued to double. As a consequence, people are using all those transistors to do multi-core processor fabrication. And so we now talk about multiple core processors, multi-core processors. That's really become the way that people leverage Moore's Law and the continued doubling of transistors every few years. Now, there's also been a number of advances in software in order to try to take advantage of that hardware, the hardware that's available at scale. And so we'll talk a lot about that in this course. I've taught courses on concurrent and parallel program design and implementation for decades. And it's been my experience that the best way to learn about parallel programming for different kinds of computing form factors, not limited, but including mobile devices and mobile apps, are not best learned through generalities or platitudes or understanding concepts in isolation. In other words, sitting and thinking is not sufficient to become an expert. Instead, it's better to see by example how these programs can be made easier to read and write, easier to maintain and modify, and of course, more efficient and resilient, meaning that they'll scale up, taking advantage of the hardware resources, and they're going to be more resilient to various types of failures and attacks. And the way that we're going to do that in this course is by applying time-proven software patterns, as well as object-oriented and functional design and programming techniques. So one of the key things to keep in mind is this course will involve lots and lots of hands-on software development, as well as testing of the code you develop to make sure it works properly. So let's talk a bit about what we're going to cover in the course. The main focus of the course will be three key Java parallelism frameworks, something called parallel streams, something called completable futures, and something called reactive streams. You'll see when we talk about each of them that they relate to each other in interesting ways. They share a lot of code in common in some ways, especially the more infrastructure code like Java collections code, but they also provide different paradigms, and they have different types of object-oriented and functional programming features from Java that are also applied in order to give them their particular characteristics, their particular charm, if you will. We'll also be spending some time talking about modern web programming platforms, and you'll get a chance to apply those in practice. In particular, we're going to be focusing on Spring Boot 2.0, including the so-called Reactor framework, and you'll see that there's a couple of different variants of this. One is based on something known as the servlet stack, which uses synchronous blocking I/O to have one request per client thread. That approach is the more traditional way of doing things. It's often known as Spring Web MVC. And you'll see also there's something called a reactive stack, which supports non-blocking asynchronous communication using something called Project Reactor, which is a Java implementation of the reactive streams paradigm. The reactive stack is often known as Spring WebFlux, and you'll get a chance to play around with both. The real focus here is going to be on WebFlux, but you'll get a little bit of practice with Spring Web MVC as well. And of course, we'll talk about patterns for parallel programming. I've written many books and articles on patterns over the years, and I find it invaluable to help people see the bigger picture of what we talk about conceptually and how those things get applied in design of object-oriented, functional, and reactive systems. I'm going to assume that you already know or can quickly learn modern Java, which is basically Java 8 and beyond, Android, which will include Android Studio and the Android SDK, as well as Git, which is a source code control management system. If you take a look at item number 12 in my frequently asked questions file at the link at the bottom of the slide, you'll get an overview of what these different assumptions mean and where you can go for further knowledge if you need some refresher on what these things are. We'll talk some about these tools and techniques in the class, but I'm assuming that you can get up to speed pretty quickly. So speaking of the class, let's take time to talk about the structure of the lecture material. So kind of in accord with what I just talked about with a little bit more structure, there are three main modules in the course. There'll be a focus on Java parallelism. These are the Java parallel programming frameworks, parallel streams, computable futures, and reactive streams in the form of something known as RxJava or Project Reactor. There's this mobile to web communication focus, which will involve Spring WebMVC and Spring WebFlux. So we'll have Android clients talking to Spring-based servers, communicating and exchanging information back and forth. And then also, as I mentioned before, we'll talk about various parallel programming and communication patterns. So they're patterns that help see how the various ways that we provide parallel programming capabilities are based on time-honored design and implementation models and architectures. The course is composed of a bunch of lessons. Each of these modules will have a whole bunch of lessons. Each lesson is composed of parts. Each part will be a single lecture. And as you'll very quickly see, I'll be uploading screencasts of each lecture part, as well as the PDF versions of the slides that correspond to those lecture parts, to my website. And I'll give you a tour of the website here in just a little bit. Each part will be composed of segments, and you'll get a chance to learn about how all the different pieces work. There will be bi-weekly quizzes on the material covered in the lectures. Here, bi-weekly means once every other week, not twice a week. That's always a little confusing. And the first quiz will be on Wednesday, August 31st. All the quizzes, the exams, and so on will be closed book, closed note, closed internet, and they'll be given on the Brightspace platform that you've undoubtedly used at various points along the way. As always, if you have any questions about Brightspace, please don't hesitate to ask. Since we have a relatively reasonably sized class, we'll strive to hand back and review the quizzes at the start of the next class. So we'll try to get your scores back and comments back very quickly by Monday, because every quiz will be on Wednesday. And then I will go over the contents of the quiz and give answers in classes on Monday, and you'll have a chance to ask questions if you have anything that needs to be clarified. The best way that you study for quizzes is by reviewing slides and watching the screencasts that are available at my website. And we'll take a tour through my website here in just a little bit later on in the overview. Depending on various factors, there could be a cumulative final exam that covers the material in the lectures. If we have such an exam, it'll kind of focus on the last few weeks of the semester. But in theory, you should kind of know what we covered the whole class. If we do have a final exam, it'll be held on Friday, December 16th from 2 to 5 p.m. using Brightspace, just like all the quizzes. The reason I say may have a final exam, typically we have programming assignments, and it's sometimes hard to know how long they're going to take because it really is based on how quickly people are mastering the concepts covered in the exams and the programming assignments. And so as a consequence, it might be the case that we have a programming assignment that ends up spilling over into exam week to be finished. And in that case, I won't give you a final exam because it doesn't seem appropriate to have you finish up an assignment and study for an exam during exam week. So either we'll finish up all the programming assignments before exam week, or we won't have a final exam. If we do finish up the assignments, we will have a final exam. So that's the end of part one of my overview of CS 253.